Let's see if we can use that knowledge now to try to make sense of this. So determine the derivative of the function and then determine the instantaneous rate of change at 2, right? The instant speed. Well, since it's f of x, I'll use f prime. Okay, well, what's the pattern? Well, we always do is we multiply this out here, bring it out here, so we get negative 4 x to the, now we subtract 1, and we get negative 3. Okay, well, I want to be able to rewrite this. I want to be able to rewrite this because I need to plug in 2 into here. Okay, and these have to be done without a calculator. Well, just like I showed you, this is just going to be negative 4 over x to the third. Okay, the negative means you're going to divide the x to the third power on the denominator. That's all. Now let's plug in 2, and now we can solve this without having to use a calculator. Negative 4 over 2 to the third power. Well, that's negative 4 over 2 times 2 times 2 is 8, and that simplifies to be negative 1/2. There it is. And that's how it works. So we can finally conclude f prime of 2 is equal to negative 1/2. All right, let's get a little visual. Let's see if we can figure this out visually. So determine the derivative of the function f of x is equal to 1 over x squared at the instant speed, and then find the instant speed at x equals 1. Okay, well, here's the problem. This is right now dividing, and this is why we went over this, because I want to be able to rewrite this so that we have some kind of power up here where we can bring down and then subtract by 1. Well, this is going to allow us to use our knowledge of negative exponents. All right, and this is just going to become, well, there's a 1 here, 1 times x to the negative 2, because we're rewriting it where this is going to tell us, again, you know, if I wanted to, I could go back to here. The reason why we do that, okay, let me just rewrite it now nicely. F of x is equal to x to the negative 2 is because now I can use that little shortcut, the power rule that we learned. Now I can bring the negative 2 down, so I'll get negative 2 x to the subtract 1, and we get negative 3. Well, now what do you do? Well, now we can rewrite this. F prime, we write this as f prime of x is equal to negative 2 over x to the third. And now we just plug in 1, and I get negative 2 over 1 to the third power. That's just going to give me negative 2 over 1. So we can write f prime of 1 is equal to negative 2 or negative 2 over 1. And this is going to tell me my instant speed at that location. My instant, I should say, slope. So let's look on this graph. This graph is the equation and graph match up. Well, at 1, look, if I was to draw this line, is it positive or negative? Well, it's negative. That's why this is negative, okay? Now, negative 2 over 1. Well, that just means I'm just going down 2. So 1, 2 over 1. And then I can go the other way. And there it is. I get my instant speed at that exact location, my friends. And that's how we can work with negative exponents, all right? Pretty challenging stuff, but let's go ahead and just try this out. So y is equal to this. Determine the derivative at 1. Okay. Well, first things first. This already has an exponent up above. We're good. What about this one? Well, right now we don't know how to take derivatives with a division sign, so we need to rewrite this. So let's rewrite this as 4x to the negative 4, just rewriting it, plus 3x to the negative 3 plus 1. Let's determine the derivative of this function, dy dx. Well, you bring the negative 4 down, so we get negative 16x to the, and subtract 1, negative 5. Bring the negative 3 down, we get negative 9 because we're multiplying them. X to the negative 4, and the derivative of 1 is 0, that's gone. Okay, let's rewrite this over here. Okay, this is going to be dy dx is equal to negative 16 over x to the 5. Okay, again, negative exponents just means put it on the denominator, you're dividing, minus 9x to the 4. Now we can plug in 1, dy dx at 1, negative 16 over 1 to the 5th, minus 9 over 1 to the 4th. Well, 1 times 1 times 1 times 1 times 1, basically 1 multiplied 5 times is just 1. Negative 16 divided by 1 is just negative 16 minus, same concept here, minus 9. So we get dy dx at 1 is equal to negative 25. And there it is, my friends. That's how we make it work. Okay, well, let's take a look at this next one. Find the derivative and then plug in 2. All right, well, we take our derivative. First, let's look at it. Do I need to rewrite anything? No, I don't need to, because every term here has an exponent that we can deal with. So negative 4 times negative 2, that's negative 8, x to the, subtract 1, negative 3, plus, bring the 2 down. Well, the 2 is going to multiply on the numerator, right? So it's going to be 2 times 1, so 2 over 4, x to the, subtract 1, and we just get 1. And then what's the derivative of 4? Well, 4 is just a constant, no rate of change, gone. So we get f prime is equal to negative 8. To rewrite this, negative exponent means you divide by it, whatever the exponent is. All right, plus 1/2 times x. Okay. Again, this x is going to multiply with this 1/2, or the x will multiply with the 1 on top, numerator to numerator. Let's plug in 2. So we get f prime of 2 is equal to negative 8 over 2 to the 3rd plus 1/2 times 2. F prime of 2 is equal to, well, negative 8 over 8 plus 1 times 2 is 2 over 2, which is going to be 1. So f prime of 2 is equal to negative 1 plus 1, which is 0. That means that if I bet you we were to graph this, we basically found the derivative at some kind of hill. Oops. At some kind of hill, right? Where here it's horizontal and it has a slope of 0. Okay, I'm hoping you kind of get the hang of this. So we'll just do one more. Okay, right here. Okay. Do I need to rewrite anything? This should be a positive. So let me just write this. Y is equal to 3 over x to the 4 plus 5x to the 7 plus pi. Okay, do I need to rewrite anything? Well, I sure do. Because I have this on the denominator and I want to put it back on the numerator. So it's just going to be 3x to the negative 4 plus 5x to the 7 plus pi. Pi is just 3.14, right? It's an approximation for this number that goes on forever. Take our derivative. dy dx, my friends. And negative 4 times 3, negative 12, x to the negative 5. 7 times 5 is 35, x to the 6, because I subtract 1. Derivative of pi, well, that's just the number, gone. I can rewrite this to finally be negative 12 over x to the 5th plus 35 x to the 6th. And now when I go to, well, look, I didn't even need to plug a number. I just wanted to find my derivative function. And there it is. Okay, so hopefully you kind of got the hang of this.